So starting from chapter 28, we will start to learn about the B field. Okay, so actually for the textbook, it always called the B field the magnetic field, but I will say B field in most of the other materials should be called the magnetic flux density. Magnetic flux density. I don't try to correct all the terms here in the slides, okay, yeah, because it occurs very frequently. I must miss something, okay, so to avoid you misleading, okay, some misunderstanding, I try to remain it to be magnetic field, but every time it appears to be magnetic field should be the magnetic flux density referring to the B field. So I try to call it B field every time. Okay, so for the magnetic field, it refers to the H field. Okay, the H field. Yeah. So I don't try to repeat this statement again. Okay, so try to make it B field is the magnetic flux density. Yeah, and I don't try to use the word magnetic field here. Okay, so first part we will talk about the magnetic field, and of course in this chapter we try to learn what we try to learn in this chapter is if we have something called B field, okay, so and then we have some moving charges, okay, moving charges in the B field, okay, what will be the interaction between the B field and the moving charges, okay. Just like at the chapter 21, okay, we try to learn the interaction between two charges, okay, or even more charges, okay. So for every two charges, there will be Coulomb's force, either attracting or repelling. So here, we assume there is something called a B field, okay. We don't try to think, okay, what is generating this B field, okay. We will learn it in the next chapter. In the chapter 29, we will try to learn, okay, maybe the current can generate the B field, okay, or some structure can also generate B field, okay. So chapter 29 will tell you, okay, how to generate this B field, okay. But here we try to believe, okay, there is something called a B field, and we try to know, okay, what is the interaction between moving charges inside the B field. Okay, so the phenomenon will be like, okay, if we have something called a cross field, which means that we have B field and E field perpendicular to each other, so we call it cross fields. In this case, we can discover the electrons, okay, so it must be negative charge, it can be positive charge, and also another experiment called the Hall effect or the Hall experiment, okay, so this is the ultimate, okay, so the ultimate one, so to a very clear evidence that, okay, so the moving charges in the wire must be negative charge, must be negative charge. It can't be positive charge moving in the opposite direction. Okay, so and then we will also learn, okay, so we have a circulating charge particle, okay, if we have some charges moving in the cross field, okay, so there will also be or I should say, if there is some charges in the B field, okay, in the uniform B field, okay, there will be circulating charge particle, and then using this phenomenon, okay, we can generate we can create some particle accelerator, okay, particle accelerator. 粒子加速器 accelerator, okay, accelerator particle accelerator, okay, so namely the cyclotron and synchrotron, okay, we'll learn a bit about it later. So and then the magnetic flux on a current wire, and then the torque on a current loop, and then finally magnetic dipole moment. Okay, we have learned the electric dipole moment before, so here we also have the magnetic dipole moment. Okay, so first B field. Okay, B field. Okay, so a B field or the magnetic flux density B can be defined to be a vector. Okay, don't try to repeat again. Okay, so magnetic flux density B field, okay, can be defined to be a vector quantity that exists when it exerts a force Fb on a charge moving with velocity v. Okay, so here we don't try to distinguish how to generate this B field. Okay, how to generate this B field? Just pretend there is some structure, there's something generate this B field, and then based on this uniform B field, and then we have a moving charge particle. Okay, moving in this B field, so that there will be a force acting on it. So this force or this B field will be like Fb over Q times B. Okay, so this is a scalar form. If we try to write it as a vector form, okay, which will be like Fb equals this charge amount, and then we have this velocity cross with this B field. Okay, cross with the B field. So this is the cross product. Okay, probably you should have learned it in high school physics, I suppose. Yeah. And then of course for most of these variable we know this is a force. Okay, so the force we should have SI unit of Newton. So this is charge. Okay, the SI unit should be Coulomb. C, this is velocity, meter per second. Okay, so finally, what is the SI unit here? Okay, what is the SI unit here? The SI unit for B field is Tesla. Okay, Tesla. Okay. So yeah, so this is the cross product, and if we try to make it a scalar form, it could also be like Fb equals Q is a scalar, so nothing special. So V will be the magnitude of the velocity, and then the magnitude of the B field, and then we need to multiply by sine of phi. Okay, phi is the angle between the V and B. V and B. The vector, the velocity and the B field has an angle of phi between them. Okay, phi is the angle between the blah, blah, blah. Okay, like this. Okay, so this is the scalar form of this so-called Lorentz force. Okay, so we call it the Lorentz force. 洛伦兹力. Okay, Lorentz force. Of course, for some other material, they may try to combine the electrostatic force and this Lorentz force together, so that to make it like B will be like the F will be like E times E plus, or the Q times E plus V cross B. But in this textbook, the author don't try to use this approach. They just separate that. Okay, this is the Coulomb's force. Okay, this is so-called the Lorentz force. But yeah, for some other material, they may try to combine them together. Yeah, because if you go to some even more high-end or advanced physics, okay, they will consider the Coulomb's force and the Lorentz force can be, it's actually the same. Okay, it's actually the same. So especially when you try to apply some relativity here. Okay, relativity 就是用上相对论的话，就是它们其实是同样的一个坐标里面的东西，就是你是换个角度看，哦，它就是电力，换个角度，它就变成磁力。 OK, so anyway, just go back here. So here first of all, we try to let you know, okay, what is the cross product. Okay, so how to determine the direction. Okay, how to determine the direction. So of course we have Q times V cross B. Okay, so Q of course Q can be positive or negative. So if Q is positive, then F should have the same direction as V cross B. If Q is negative, and then F has an opposite direction to the to the V cross B. So we just try to isolate. Okay, so we only want to talk about this V cross B. So let's say for this one, okay, for this one, we have V pointing to this direction, B pointing to that direction. So of course they should have an angle between them. And then we always, okay, of course this is called phi. And then we always make this phi is smaller than or equal to, okay, is larger than or equal to 0 degree and smaller than or equal to 180 degree. Okay, should be strictly between them. Okay, otherwise it will be a problem. Okay, so which means that you try to use your 4 fingers. Okay, your 4 fingers pointing to the direction of V. Okay, so here we have V cross B. Okay, V cross B. Okay, so for this cross product, the order is important. Okay, V cross B and B cross V are not the same. Okay, B cross V are not the same. They have a negative sign between them. Okay, so the order is important. It's not like A times B. A times B equals B times A. They have commutative law. But for the cross product, if you reverse the order of the cross product, there should be another negative sign. So pay attention to that. Okay, so here you use a 4 finger pointing to the first vector, which is V in this case, and then you try to rotate your wrist, okay, so that your 4 finger pointing to the B, okay, and then your thumb will point to the direction of V cross B. So this is the direction of V cross B. And then to keep in mind that this phi should be less than 180 degree, less than or equal to 180 degree. Don't try to make it like, okay, I try to make it like V is like this, and then I try to rotate it more than 180 degree, okay, then. And then the V cross B is upon to opposite. This is not correct. Okay, so make sure that this phi is between 0 and 180 degree. Okay, so this is I think you should have learned this so-called the right hand rule. Okay, we always use right hand rule. Always use the right hand rule. Right hand rule. Okay, so right hand rule. Okay, right hand rule. Okay, we always use right hand rule. Right hand rule. Okay, so here just let you know a bit about the cross product and the dot product. Okay, so here if we have a V cross B will be like, okay, suppose this is V, this is B. Okay, just now we already know that, oh, if it is phi, so that we have V and then B and then we cross. Okay, so of course this is like a 3-dimensional stuff. Okay, so we have a V cross B here, okay, in this direction. So just imagine, okay, it will be like yeah, this is the x-axis, this is somehow like the y-axis, this is the x-axis. Okay, so this is somehow like the z-axis. Okay, so this is the direction. So what is the magnitude of V cross B? So V cross B will be like this parallelogram. Okay, the area of this parallelogram. Okay, so this is the area of this parallelogram will be V cross B, the magnitude of the V cross B, or the absolute value of the V cross B. So usually if we try to write it as an absolute value of a vector, which means that the magnitude of it. Yeah, because this is VB sine of phi, okay? If you still remember, if this is a triangle, suppose this is V, this is B, okay? So the area of the triangle will be like half of B times V times sine of phi, okay? So like I think it's the law of sine, okay? 正弦定理是这个吗？好像是吧？还是说不是？正弦定理是另外一个东西 ，OK？ 跟那个什么 y 什么 y 接圆有关。OK， 所以不是。反正这个三角形的面积的话，就是1/2 b times v times b 乘以 sin of phi，OK？ 所以2倍的话，就是这个平行四边形的面积。OK，so actually the area of the parallelogram. Okay, so this is the direction and also the magnitude. And for the inner product, okay, if we have a dot b will be a times b cosine of theta. Okay, which means that if we have a like this, if we have b like this, okay. So and then we have an angle here, theta. So which means that if we just write a line perpendicular to the vector A, this is perpendicular, and then this is B, this is A. So for this part, will be like B times cosine of theta. So this is like the projection of vector B or vector A multiplied by the magnitude of vector A. So this will be like this one times this one, okay? Or if you like, you can also project this one there. So this one could be like A cosine of theta. So it will be like this one multiplied by this one, okay? They are the same. So these are the two geometric meaning of the inner product and outer product. Okay, so besides, I try to supplement something for the unit vector notation. If you hopefully remember the unit vector notation for the inner product will be like if I dot I, j dot j, k dot k will be 1, okay, and other combination will be 0. But here we will have something different. Okay, so we will have, let's say I cross I will be 0. Yeah, will be 0 vector. J cross J will be also 0 vector. K cross K will be also 0 vector. Okay, and then we have I cross J. I cross J will be K hat. Okay, I cross K will be negative J hat. Okay, here we have a J cross K will be I hat. J cross I will be negative K hat. Finally, K cross I will be J hat. And then this is K cross J will be negative I hat. So which means that somehow like opposite to the inner product. Okay, if you have the same unit vector dotted with itself, then it will be a zero vector. It will be a zero vector. Yeah, because you multiply by cosine of sine of 0 degree. Okay, you have a sine of phi. Sine of phi. Okay, if v and b are the same vector, then or parallel to each other, then this phi will be 0. Sine of 0 will be 0. So if unit vector dotted with cross it with itself, it will be 0 vector. But for other, it will be another combination. So it is quite difficult to memorize. So what make it easier is like if we try to make it like ijk, you try to write it something like this. If it is clockwise, it will be positive. If it is counterclockwise, it will be negative. What does it mean? What does it mean? What I mean is that if we have maybe I just copy it as okay, just create one more copy. Okay, so which means that if we try to go from I cross, okay, pass through this positive sign, okay, it becomes positive k, so on and so forth. If it is j cross k, so it will be positive, becomes a I. K cross I will be positive j. But if it is counterclockwise, which means that if we start from I, cross it with k, okay, it will go through negative side. It will be negative j. I cross k will be negative j. And then k cross j will be negative I. J cross I will be negative k. So if we go clockwise, it will be positive side. Okay, clockwise. I cross j will be k. J cross k will be I. J cross k will be I. And then k cross I will be j. K cross I will be j here. And then if it is counterclockwise, I cross k will be negative j. I cross k will be negative j. This one. And then k cross j will be negative I, which is this one. And then j cross I will be negative k, will be this one. Okay, so we have a negative side here, negative side here, negative side here. If you go counterclockwise, but you have a clockwise. For clockwise, you have a positive. Value, like this. So also for the three-dimensional Cartesian coordinate, like x, y, z, okay, if we have a x, y, and z, or usually we'll try to draw it like x, y, and z. We usually make it like x cross. Okay, of course this is not x is not a vector, but the x-axis, okay, x-axis crosses with the y-axis will become the z-axis. Okay, so you have x-axis crosses with y-axis will be the z-axis. So also this coordinate system follows the right-hand rule. So this is just try to repeat FB equals Q, V cross B, and then after knowing the direction of V cross B, and then try to apply the polarity of Q so that you know, okay, if Q is positive, then FB have the same direction as V cross B, and vice versa. So this is a quick checkpoint. Okay, so this is, yeah, so maybe we stop here today. We will. Yeah, so we try to stop here.